AI-powered jet engine assembly time by component. This is a prototype not for commercial. AI engine designed and visualized by Pradeep K. Suri. This Python program leverages the powerful Plotly library to visualize jet engine assembly time by major components using a bar chart. The data represents 10 key components of a jet engine, including the compressor, turbine, fan, and control unit, each associated with its estimated assembly time in hours. The use of Plotly allows for highly interactive and visually engaging charts, which is ideal for engineering dashboards and executive presentations in the aerospace sector. The bar chart is constructed by defining a go.figure object and adding a bar trace using go.bar. Each bar corresponds to a component and its associated assembly time. Additional visual enhancements such as displaying the exact time on each bar, setting the bar color to orange, and adjusting the text position improve the readability and professionalism of the chart. These design choices support quick comprehension of time distribution across engine components, crucial for optimizing processes and reducing delays in manufacturing or maintenance cycles. The layout is customized as having a dark background, which is often preferred in control rooms, technical dashboards, or presentations in aerospace industries. The chart title includes a personal touch, attributing the visualization to the AI architect Pradeep K. Suri. Font colors, axis titles, and bar gaps are all tailored to enhance clarity. Finally, Figure Show renders the chart, allowing engineers, project managers, and executives to assess which components take the most time and where efficiency improvements can be made in jet engine assembly. The image is a bar chart titled Jet Engine Assembly Time by Component. The subtitle indicates it's from a engine designed and manufactured by Precision Core, Aerospace Industries. The chart displays the time in hours required to assemble different components of a jet engine. Here's a detailed breakdown of the chart. X-axis, horizontal jet engine components. The X-axis lists the various components of the jet engine that are being analyzed for their assembly time. These components are compressor, combustion chamber, turbine, nozzle, fan, gearbox, sensors, fuel system, control unit, casing. Y-axis, vertical assembly time, hours. The y-axis represents the assembly time in hours. The scale ranges from 0 to 40 hours, with increments of 5 hours marked by horizontal grid lines. Based on the bar chart titled Jet Engine Assembly Time by Component, here are some decision support system, DSS, points that can be derived. Strategic level. Resource allocation. The data highlights the components requiring the most assembly time, turbine, compressor, casing. This information can guide strategic decisions regarding workforce allocation, training priorities, and investment in specialized tooling or automation for these critical areas to potentially reduce bottlenecks. Process improvement focus. Identifying the longest assembly time for the turbine, 40 hours, suggests this component is a prime candidate for process improvement initiatives. Analyzing the assembly steps for the turbine could reveal opportunities for streamlining, standardization, or error reduction. Cost analysis. Assembly time is a significant factor in the overall cost of manufacturing the jet engine. Understanding the time spent on each component allows for a more accurate cost breakdown and helps identify areas where cost reduction efforts related to assembly can be most impactful. Make or buy decisions. For components with high assembly times or specialized requirements, like the turbine, the company might consider evaluating the feasibility and cost-effectiveness of outsourcing their production versus in-house assembly. Tactical level. Production scheduling. The assembly times for different components are crucial for accurate production scheduling and lead time estimation. Knowing the duration for each stage allows for better planning of the overall assembly process and managing customer expectations. Workforce planning. The data can inform tactical workforce planning. Knowing the assembly time for each component helps determine the number of skilled personnel required at each stage of the assembly line. Inventory management. Understanding the assembly time can indirectly influence inventory management strategies. For components with longer assembly times, maintaining adequate stock levels of sub-assemblies might be necessary to avoid delays in the final assembly. Performance monitoring. Tracking actual assembly times against these benchmarks can serve as a key performance indicator, KPI. Deviations can signal potential issues in the assembly process that require investigation and corrective action. Operational level. Bottleneck identification. The turbine's significantly higher assembly time, 40 hours, clearly identifies it as a potential bottleneck in the overall jet engine assembly process. Addressing this bottleneck could lead to significant improvements in overall production efficiency. Task prioritization. During the assembly process, understanding the time required for each component can help supervisors prioritize tasks and allocate resources effectively on a daily or shift basis. Training needs. The data can inform the development of targeted training programs. Focusing training efforts on the assembly of time-consuming components like the turbine could yield the greatest return in terms of efficiency gains. Process optimization experiments. When testing new assembly techniques or tools, the assembly time for specific components can be used as a key metric to evaluate the effectiveness of the changes. For example, testing a new tool for the nozzle assembly would aim to reduce its current 15-hour assembly time. In essence, this bar chart provides valuable data points that can support decision-making across different levels of the organization, aiming to improve efficiency, reduce costs, and optimize the jet engine manufacturing process. Thank you.